On day 4, it's a review of the things we've learned so far. So I'm going to do a couple of examples from this page, but we won't do all of them. But it'll be a chance to catch up if we need to, if the other unit or day 3 went a little bit long, because that was a beefy unit. Okay, for this problem, let's do problem number 2. 2a asks us to find f of g of 2. So that means I would stick 2 into the g function. 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. And then stick that result into the f function. 9 plus 2 is 11. So I get radical 11. B. G of f of negative 2. Negative 2 will go into the f machine. Negative 2 goes into f. Negative 2 plus 2 is 0. Radical of 0 is 0. Stick that result into the g machine. 2 times 0 squared is 0, plus 1 is 1. F of 4. Take 4, stick it into this machine. 4 plus 2 is 6, so I have a radical of 6. And then stick that result, radical 6, back into the f machine. So we get radical of radical 6 plus 2. And then for d, it's g of negative 1. So I'll stick negative 1 in here. Negative 1 squared is 1. 1 times 2 is 2. Plus 1 is 3. Take that result and stick it back into g. 3 squared is 9. 9 times 2 is 18. 18 plus 1 is 19. So that's the end result on that problem. Next, let's do f composed with f on problem number 5. All of these will be effectively the same. What is f of f on number 5? F of x. That would mean to do f of x, which is radical 3x. Now, take f and stick radical 3x into it as an argument. So we get the radical of 3 times the radical of 3x. So that is the result for the function, the composite function. Then it asks us to do the domain. And remember, to do the domain, it's a two-step process. First, find the domain of the original function, so the original input, which was f. So there I would need 3x to be bigger than or equal to 0. So I need x to be bigger than or equal to 0. That's one domain. That's what I call stage 1. And then stage 2 is to find the domain of the result, the f of the radical of 3x. So here we would need to make sure that this thing is defined. It's just a couple of radicals, so its domain is going to be to make sure that the radical, the 3 radical 3x is bigger than or equal to 0. Divide by 3, divide by rad 3. It's like saying the square root of x has to be bigger than or equal to 0. And that, of course, happens when x is bigger than or equal to 0. So coincidentally, they're both x bigger than or equal to 0. And our final domain of f composed f is going to be bigger than or equal to 0. So from 0 to infinity. Okay. Now let's do the graphical problem here. 8. State why the graph is 1 to 1. Well, the blue graph is 1 to 1 because it passes the horizontal line test. Then graph the inverse function. So negative 1, negative 3 becomes negative 3, negative 1. 0, negative 2 becomes negative 2, 0. 2, 0 becomes 0, 2. And 3, 3 is 3, 3. So its graph is going to look like that. Notice the beautiful symmetry that we get flipping over that black line located at y equals x. We get this nice symmetry over that line. Okay, down here, find an inverse function, check the answer. For this one, I will do 9, because 9 is one of the more complicated ones. You'll want to make sure you know this skill well for when we're getting close to tests, my friends. Y equals 2x plus 3 over 5x minus 2. Switch x and y. 2y plus 3 over 5y minus 2. Cross multiply. 5xy minus 2x equals 2y plus 3. Collect like terms. 5xy minus 2y equals 2x plus 3. Factor out the y. Y times 5x minus 2 equals 2x plus 3. And then divide. 2x plus 3 over 5x minus 2. And then ensure full credit. F inverse of x equals 2x plus 3 over 5x minus 2. Okay? Checking your answer would mean to find f of f inverse of x and f inverse of f of x. This becomes quite labor intensive, so I will do that in class tomorrow. It'll take me about 5 minutes to do one of those, maybe both of them in class. I just don't have a lot of room in here, so I don't want to do it on this particular video. Sketch the graph of the following functions. Identify intercepts, two other points, equations of asymptotes. Let's take this one. So this is exponential, but it's a 1/2. So this is exponential decay. So I'm expecting the graph to look like this. There is no vertical shift, so I'm actually expecting it to have its asymptote still located at y equals 0. And it will have a bit of a stretch factor going on here, so let's just make a t-table for this one for the purposes here. xy, so let's plug in 0 and 1 and -1. So 1/2 to the 0 is 1. That was our parent point, but then we have a multiply by 3 for the vertical stretch. 1/2 to the 1 would be a half, but then multiplied by 3. And then -1 is a flippy, so 1/2 flipped is 2, and 2 times 3 is 6. So my graph would look something like 0, 3. There's my asymptote. 1, 1.5, and 4, 5, 6, -1, 6. So my graph would look something like that. And I'm generally pretty happy with that and what I was expecting. I expected it to look kind of like this, and sure enough, it looks kind of like that. And then for our last example in this video, let's do 38. So 25 and 5. Oh no, let's do 40. 40 is more challenging, because over here we have two things being multiplied. So the least common base of 8 and 4 and 2 is going to be 2. So what is 8? 2 cubed. What is 4? 2 squared. But that's to the x squared, so we have 2 to the 2x squared, and then 2 to the 5x. Now combine. 2 cubed equals 2 to the 2x squared plus 5x. Next, take a log. That's the logarithm that's going to cancel out those bases for me. And now we're into the next set of the problem, which is next steps of the problem. 2x squared plus 5x. Subtract 3. 2x squared plus 5x minus 3. Factor, let's see, plus 3 minus 1, I think. Let's see, plus 6 minus 1 is positive 5. Yes, it is. So x would be equal to 1/2, or from here, x would be equal to -3 by solving that equation.